Problem 9 says, an economist models the market for wheat by the supply equation y equals 3.32p minus 9.21 and demand equation y equals negative 0.97p plus 24.32. P is the price per bushel in dollars, and Y is the number of bushels produced and sold in millions of dollars. Okay, so I'm going to highlight a few things here that are important. First of all, the supply equation. That's important. And also the demand equation. Okay. So, part 1 asks us to use the model to determine at what point the price is so low that no wheat is produced. So low that no wheat is produced. Okay, so remember that Y is the number of bushels of wheat produced. Bushels. And we want price P so that no wheat is produced. Okay. So I'm going to take the supply equation and I'm going to set Y equal to 0. Once I set Y equal to 0, I'm going to solve for P. So also, just as an aside, when you're doing this problem on your own, I want you to think about why exactly we're using the supply equation for this one, for part 1. So the supply equation was 3.32 P minus 9.21, and we're setting that equal to 0. So, and I want to solve for P, right? So I can add 9.21 to both sides. And then to solve for P, I will divide both sides of this by 3.32. And I'm going to plug that into a calculator because I can't do that in my head. 9.21 divided by 3.32 is 2.77. So my final answer for part 1 is at the price of $2.77 per bushel, no wheat is produced. And that's my final answer for part 1. Make sure you use units. Okay, on to the next one. Use the model to determine at what point the price is so high that no wheat is sold. So we need to go back up here and use the demand equation. So just like before, we want P so that no wheat is purchased. because there's no demand. So from above, we have that the demand equation was negative 0.97p plus 24.32. Let's double check that. 24 point, yeah, okay. So just like in part 1, we're going to use the demand equation instead of the supply equation. We're going to set y equal to 0, which we've already done, and then solve for p. And again, when you're doing this on your own, I really want you to think about why we're using the demand equation for this one. So let's solve for p in this equation. The first thing I can do is subtract 24.32 from both sides. And then I can divide both sides by negative 0.97. So that p is equal to negative 24.32 divided by negative 0.97. And again, I'm going to put that in the calculator. So negative 24.32 divided by negative 0.97 gives me 25.07. So my final answer for part 2 is going to be at the price of $27.07 per bushel. We'll do words here. No wheat is sold. Because the price is too high. And that's going to be our final answer for part 2. Okay, on to part 3. I want to find the equilibrium price and the quantities produced and sold at equilibrium. So remember, the equilibrium price is going to be when both equations, so when the supply equation is equal to the demand equation. So what I'm going to do here is I'm going to take the supply and demand equations, I'm going to set them equal, and I'm going to solve for a variable. And I'm going to use that to solve for the other variable. So this is exactly like problems, I guess, 6, 7, and 8 on the practice exam, except now our equations are a little bit messier. So the supply equation was, let me write this down, 3.32 y equals 3.32p minus 9.21. And the demand equation was y equals negative 0.97 plus 24.32. Okay, I'm going to put that off to the side. So since these are already in slope-intercept form, what I can do is just set the values for y equal to each other. So when I set them equal, I get 3.32p minus 9.21 equals negative 0.97p plus 24.32. And then I want to solve for p. So to do that, I should probably get all of the p's on one side. So I'll add 0.97p to both sides. And I'll use the calculator for that. So 3.32 plus 0.97 is 4.29p minus 9.21 equals 24.32. And then I'll add, let's do that in another color. I'll add 9.21 to both sides. Again, on the calculator, 24.32 plus 9.21 is 33.53. So I have 4.29p equals 33.53. To solve for p, I'll divide both sides by 4.29. Okay, so when I do that, on the calculator, I get 7.815. I'm just going to round that up to 7.82. Okay, so the equilibrium price is $7.82 per bushel. But remember, in the statement of the problem, I wanted the equilibrium price and quantities produced and sold. So I'm only halfway done. So for the quantities produced and sold, at equilibrium, I'm going to use P equals 7.82 and plug it into supply or demand equation. To get Y. I'm just going to use the first one. That seems easier. So that's the supply equation. I've got Y equals 3.32 times 7.82 minus 9.21. When I put that into the calculator, I get 16.75. So the quantity produced at equilibrium is going to be 16.75 million bushels. And that's our final answer.